Hey, beautiful people, this is Mr. Knight. This is our Pre-Algebra 6.4 video, similar and congruent figures. So let's go get started. Excuse me. Similar figures. So the vocabulary. Two figures are similar figures if they have the same shape, but not necessarily the same size. So two figures are similar. And right above the word similar, I'm going to put the sign. So that's the word similar, just like that's the word equals. This is the word similar. Okay. Similar figures. If they have the same shape, but not necessarily the same size. I'll give you an example of that here in 1 second. Same size. Okay, so let's assume that I have this figure, and let's do this. Oops, that's not what I wanted. Copy. Why does it keep giving me a D there? Copy. Aw, this is not being nice. Paste. There you go. So, these are similar figures. They're the same shape, but not necessarily the same size. It could also be smaller, okay? So now, let's look at corresponding parts, and I'll use those same two figures that I did. So, corresponding parts of figures are sides or angles that have the same relative position. So, these are sides or angles that have the same relative position. Okay? And let's see. Let's move this. All right, so I'm going to give you an example here. Let me just move it up here. All right, so we're going to look at corresponding parts. So if you take one figure, if two figures are similar, and I take one and lay it on top of the other, these sides right here is what we will call similar. That angle to that angle. Let's see, this angle to that angle, that side to that side, those are corresponding, and let's do this. That angle to that angle, and that side to that side. So that's what we mean by corresponding sides. They have the same relative position if you lay one on top of the other, okay? So now congruent, our last vocabulary, two figures are congruent if they have the same shape and, abbreviate the word and, same size. Alright, so that means congruent. So congruent would be, let's draw this, and let's see if I can, yeah, there we go. Copy, and let's see if we can't paste. Alright, those two are congruent. If I lay one on top of the other, they're identical, okay? So those two triangles, and it doesn't have to be triangles, it could be rectangles, any type of polygon, any type of quadrilateral, okay? So let's move on. Okay, properties of similar figures. Here you go. Here, all right. Properties of similar figure. This right here is what we call a similarity statement, if you will. It's a key to a puzzle. It's your decipher for a code, if you will. They're telling you the triangle, that little symbol right there just means triangle. There's your similar symbol right there. So it's saying triangle ABC is similar to triangle DEF. So it's telling you how to line things up. So let me erase this real quick and I'll show you what I mean by that. So when I talk about lining things up, I know that A goes with D, B goes with E, and then C goes with F. And then if I look at actual, now those are angles, okay? So I know that A and D go together, those two go together, C and F go together, B and E go together. So it tells you how to lay one triangle on top of the other. The purposes of that is to figure out what corresponds to what. A lot of times you may have to let's say that I had this type of figure right here, okay? And let's copy that real quick. Oh, or, how do I get or? I guess it's doing like text recognition. Let's see, copy, paste, there you go. So let's say I had those two figures, but let's say that one was rotated. A lot of times you'll see them rotated. So I need to know how to line those things up so I know what corresponds to what. Now, my particular figure, it may be kind of easy to determine, but some of these figures, like in specific triangles, you may not be able to tell. So that's the purpose of this key. Then I also know if I look at AB as a line segment, sorry about that. If I look at AB, let me move this back. Yeah, there you go. If I look at line segment AB, where's AB? AB's right here. So if I look at that line segment, I know that it corresponds to DE. I know it corresponds to DE, okay? And then if I look at BC, that corresponds to EF. So BC corresponds to EF. And then obviously one last one, A and C, D and F. So A and C, D and F. So it also not only tells you what angles line up with what angles, it also tells you what segments line up to what segments, okay? Anyway, let's get back to our properties here. So our first property here, corresponding angles are similar of similar figures are congruent. That means they're identical, same value, same measurement. So A and D are congruent, and that's a congruent symbol right there. Your congruent symbol. That is a similar symbol without the equals, okay? B and E are congruent, C and F. So if these are similar figures, then these angles, corresponding angles, are congruent. The second piece of that is the ratios of the lengths of the corresponding sides are equal. What they mean is that if I take the ratio of, let's see what they did. They did AB, DE. So AB, let me erase some of this here. Let's erase some of this right here so I can do this again. All right, so they're saying AB, I'm looking down here, AB, all right, they're taking that AB, which is 5, right? And then they're saying DE, which is 10, all right? Now let's look at BC. BC would be 3, and EF, yes, would be 6, and one last one here. We'll do the blue. We're looking at AC and DF, this one right here. AC would be 4, and DF would be 8. And then if you reduced all those, this gives me 1/2, right? This gives me 1/2, and this gives me 1/2. So if you notice, all these ratios are the same. All right, that's what it means in this definition right here in number 2. The ratios of the lengths of the corresponding sides of similar figures are equal. And we notice that all of those are equal. All right, so now your turn. So if you would pause the video, run through this question, this checkpoint, this number 2, and then start the video back up and we'll check our answers, okay? Okay, so for number 2, it says given FGHJ is similar to KLMN. So remember, this tells me how to set it up. The F and K go together, the G and L go together, H and M go together, the J and N go together. To find the ratio of the lengths of the corresponding sides of those two polygons. Okay, so we know that. Okay, so let's just pick two sides here. We know we have FJK, so I know I'm going to look at this to this. Now, the other thing is they're telling you how to set this up. They gave you this figure first, and then they gave you that one second. So if you remember when we went through ratios, we looked at what they gave us first, what would have been the first. So we could say 8 to 6. We could also say 8 over 6. So notice that value goes first, and then the second thing would actually go next. Okay, so 8 to 6, or 8 over 6, and you can reduce that to 4 over 3. So that would be my ratio of the corresponding sides. And you could look at any of the others. Let's do one more. Let's do GH and LM. GH is 16, and LM would be 12. Again, divide both by 4, and you get 4/3. You get the exact same ratio, okay? All right, move on. All right, so example 1, identifying corresponding parts of similar figures. This one should be pretty easy. We'll just breeze through this real quick. We know that here's our key, our legend, if you will, our decoder. So we know that X and U go together. So we know that angle X and angle U go together. So angle X is congruent to angle U, and then angle Y is congruent to angle V, and then angle Z is congruent to, congruent to angle, what is that, angle W, Okay, now if I look at corresponding sides, we know that corresponding sides would be XY, and UV. And then we also have YZ and VW, and we also have XZ and UW. Okay, UW. So those are corresponding sides. So we're just, instead of pausing the video, we're just going to run through this checkpoint, this number 1, real quick. This should be fairly easy. You know that when we look at corresponding angles, angle T is congruent to angle X, because you know that T and X go together. And then you know angle U is congruent to angle Y. We know that U and Y go together. We know that S and W, so angle S is congruent to angle W. And then the last one would be V and Z. Angle V is congruent to angle Z. All right. And then if you look at the corresponding sides, I'll pick a different color here. Corresponding sides, you know that ST and WX, and then we also know that TU and XY. We also know YZ and UV. Let me back up. TU, XY. I messed up there. My brain's going faster than what I could write. Okay, so we need UV, and we need YZ, and then our very last one would be VS and ZW. Okay? Alright, so let's move on. Example 2, finding the ratio of corresponding side lengths. Okay? So this one we've already done too, so we're going to, this should be fairly easy. We need to make sure that we understand the key here. All right, so we have given ABCD is similar to QRST. It says find the ratio of the lengths of the corresponding sides of ABCD to QRST. So we know that AD goes in here, different colors. So we know that AD goes on top, or is the first before the colon, and then we know that QT would be the second piece of that. So AD, let's see, AD would be 8. AD is 8. And then QT would be 10. And then if I reduce that, I would get 4/5. So my ratio would be 4/5. That'd be this right here. Okay, 4/5. So that was pretty easy. Let's move on. So now let's look at example 3. Finding measures of corresponding figures. So obviously you're going to have an unknown, and then but you can use the ratio and a proportion to figure out what your unknown is. Okay. So anyway, it says given DEFG is congruent to KLMN. It says find the indicated measure. Find KL. So we need to find KL. All right. So because the quadrilaterals are congruent, the corresponding angles and are congruent, and the corresponding sides are congruent. So that right there was my key. It told me they're congruent. That means the corresponding angles are congruent, corresponding sides are congruent. So this makes it kind of easy. My corresponding side would be DE. KL and DE. And so we know that DE, it's congruent to DE, okay? And so KL is equal to DE, which is equal to 8 feet. Okay, so that's my answer on that one. And then I need to define angle L. We know that angle L is congruent to angle E, so the measure of angle L is equal to the measure of angle E, which is 111 degrees, which would be that angle right there, okay? So, your turn. This is your checkpoint. So given triangle ABC is congruent to triangle LMK, you want to find angle L. So if you need, pause the video real quick. Once you finish, start the video back up and we'll check our answers together. Okay, if I look at my key right here, I know I'm looking for angle L, right? Well, L goes to A. If I look at my key, so there's A, there's L, A is 58, and I know if these are similar, or the congruent triangles, so I know that angle L is congruent to angle A, so therefore the measure of angle A is equal to the measure of angle L. Measure of angle A is 58 degrees, so therefore the measure of angle L is 58 degrees. So it's 58 degrees, that would be our answer on that one. Okay. So, that was it. We are done. Let me make sure. Yeah, we're done. So that was it. So that's the end of our video. Have an awesome day. Have a beautiful day. Be safe, and we'll see you next video.